Do you know the geochemist who helped ban above-ground nuclear testing and basically saved the world? Hi, I'm Taylor from WowSTEM, and that geochemist was Dr. Katsuko Saruhashi. She studied the radioactive isotopes produced in nuclear blasts, which are radioactive and dangerous atoms. Dr. Saruhashi looked at the concentration of these isotopes in rainfall, dust, and in the ocean around Tokyo after nuclear testing in the Pacific Ocean. Nuclear weapons were a brand new issue in Katsuko's early career in the 40s and 50s. The immediate dangers of nuclear bombs was devastatingly clear after the bombings of Hiroshima and Nagasaki in 1945. But the longer-lasting effects of the radiation weren't yet fully understood. Between 1951 and 1958, there were over 250 nuclear tests in the atmosphere. That's a rate of almost 3 nuclear explosions each month. Dr. Saruhashi realized that these tests were dangerous, not just for the people near the explosions. She found that these nuclear tests were putting harmful materials into the atmosphere, called nuclear or radioactive fallout. And these radioactive materials could travel thousands of miles across the ocean and stick around for decades. Thanks to her work, the world realized the dangers of these tests, and a treaty was signed to ban nuclear testing in the ocean, atmosphere, and outer space, called the Partial Test Ban Treaty. So how did Dr. Saruhashi use geochemistry to save the world? Katsuko Saruhashi was born in Tokyo in 1920. She was a curious child and always wondered about the science behind rain and raindrops. She went on to earn a degree in chemistry from the Imperial Women's College of Science in 1943. She then worked at the Meteorological Research Institute until completing her PhD in chemistry at the University of Tokyo in 1957, where she invented a new way to measure the amount of carbon in the ocean. Dr. Saruhashi kept that wonder of the natural world as she became a geoscientist, a scientist that uses chemistry to understand geology. After World War II, Dr. Saruhashi worked at the Central Meteorological Observatory of Japan, where she was asked to lead a research project on the long-term effects of nuclear testing in the Pacific Ocean. As a geochemist, she had to understand the chemistry of nuclear fallout and the geology of how this fallout could travel hundreds or even thousands of miles away. Why is nuclear fallout so dangerous? The immediate dangerous zones of nuclear explosions range hundreds of miles, but the long-lasting isotopes blown into the stratosphere can travel thousands of miles and cause issues for decades. An isotope is a type of atom with a different number of neutrons in its nucleus. If an isotope is in an unstable energy state, it will randomly emit energy in the form of radiation to get to a stable state. This is what makes isotopes radioactive, and that emitted energy can be hugely harmful to our cells. Each decay is random and has a certain probability related to something called the half-life of the isotope. The half-life represents the amount of time it would take for the isotope to be reduced by half. Different isotopes have different half-lives, ranging from practically instant to many years to even longer than the age of the universe. 2 of the isotopes produced in nuclear explosions are strontium-90 and cesium-137. They have super long half-lives of 28 and 30 years long. Because they won't decay away very quickly because of these long half-lives, they can travel in the wind for thousands of miles, be absorbed in water droplets and clouds, come down as rain, and even be absorbed in soil. Dr. Saruhashi developed a new technique sensitive enough to measure the amount of these isotopes in rainwater, dust, and the ocean after nuclear tests. These measurements depend on the distance and time since the last nuclear explosion. By measuring these trends, Dr. Saruhashi was able to predict the future amount of these isotopes for decades to come. She realized that if things didn't change, there would be dangerous levels of these radioactive isotopes, strontium-90 and cesium-137. With these results, Dr. Saruhashi was able to show how dangerous nuclear tests were, even for cities thousands of miles away from the testing sites like Tokyo. Dr. Saruhashi and her colleagues all over the world pushed governments to ban these tests for the collective safety of Earth's population. Throughout her career, Katsuko Saruhashi pushed for the greater good of humanity, but more personally for women in science. She was constantly breaking barriers. She was the first woman to earn a PhD in science from the University of Tokyo. She was the first woman to win the Miyake Prize for geochemistry, and she was the first woman elected to the Science Council for Japan. After all her personal success, she still made sure to support women in STEM all over Japan. She founded the Society of Japanese Women Scientists in 1958 and created a yearly award called the Saruhashi Prize, which recognizes female scientists for their contribution to the natural sciences and for their commitment to mentoring and advocating for women in STEM. By following her curiosity, paving the way for future scientists, and standing her ground in her science for the benefit of all humanity, I really do think she saved the world.
Wow!